Hi guys, Jesse here with Cisco Academy Help, the video series that hopefully helps you dive deeper into the world of Cisco, all right? My goal, my hope, is that I help illustrate the information that you read throughout the week and how it relates to the labs, and in this case, the packet tracer that they have you work on. Today's packet tracer is 4.2.4.5, connecting a wire and wireless LAN. Now, within your week's reading chapter 4, you focus that is primarily on layer 1, the physical layer, and layer 2, the data link layer. You learned within the physical layer the different types of medium that we use to connect the devices. You learned about coax, you learned about shielded and unshielded twisted pair, you learned about fiber optic cables, you learned about wireless transmission. And within the coax line, you learned about how it uses modulated frequencies to transmit the data between two different devices or multiple different devices. You learned about what makes up a coax line, how there's an outer jacket that houses a copper-cladded steel center conductor surrounded by foam dielectric and shielded by foil and braiding to prevent not only the signal from getting out of the cable, but other signal from getting into that cable. You learned about twisted pair cabling, otherwise known as UTP cabling, and how it relies solely on the twisting of the wiring to cancel the infiltration of EMI and RFI, both electromagnetic and RF signal, from degrading the signal that's inside the wire. Then you learned about fiber optic cabling and how we use different types of fiber for over different distances, and how there's a slew of different type of connectors that we use to connect different devices. And then we looked at wireless transmission, just kind of touched on it a little bit. We talked about how with 802.11, with some of the broadcast types like 2.4 gigahertz and 5 gigahertz, it primarily uses a half duplex communication between devices, which means that it can either send or receive, but never at the same time, which does slow down your speeds. But you can use what's called full duplex with an Ethernet, coax, fiber optic, and other wireless transmissions, so you can send and receive it at the same exact time. Going down from there, or sorry, not going down, but moving up to layer 2, we learned about the data link layer and how there's two sub-layers within the data link layer. You have the logical link control layer, the LLC, and how that is used to communicate with layer 3, layer 3, and what protocol it should be using, whether it's IPv4, IPv6, or any other type of protocol it could use. We also learned about the media access control layer, the MAC address layer, and how it's used as the physical address of the interface on the device that you're communicating with. You also learned how the MAC layer also communicates down to the physical layer, what protocol it should be using or what media it will be using, whether it's Ethernet, fiber optic, wireless transmission, pick your media. That's what it's used for, to communicate down to the physical layer. We also talked about frames at the data link layer and what constitutes a frame, what's inside of it, the header and the trailer, the data, and the addressing that's within that frame. We saw how it fits into the OSI model, right? The 7 layers. We focused again on layers 1 through 4, the transport layer, and when a PDU is inside that transport layer, it's called a segment, and when it encapsulates down to the network layer, it becomes a packet, right? And then that PDU again encapsulates down to layer 2, down to the data link layer, it becomes a frame. And then finally down the physical layer becomes bits. Again, I can't stress this enough. Focus on those terms: frame for layer 2, packet for layer 3, and segment for layer 4, because they stress those within the quiz questions later on, and it'll help you understand what layer they're trying to talk about. From there, we talked about network topologies. We talked about point-to-point, star, hub and spoke, ring. What else am I forgetting? Full mesh topologies, and the strengths and weaknesses of each topology. So finally, we want to take what we learned and see how it relates to the lab. So for that, we'll go ahead and we'll click on the packet tracer and go down to our objectives. We have 5 parts here. We have connecting to the cloud, part 1, connecting to router 0, part 2, connecting remaining devices in part 3, and verifying connections in part 4, and then finally examine the physical topology. Now I'm going to do my best to try to give you some more tips and tricks as I go through the packet tracer and how you can visualize more information that's happening on the packet tracer. The background that they give us is when working in packet tracer, a lab environment, or a corporate setting, you should know how to select the appropriate cable and how to properly connect devices. The activity will examine device configurations in packet tracer, select the appropriate cable based on the configuration, and connect the devices. This activity will also explore the physical view of the network in packet tracer. So scrolling down from there, we'll talk about part 1, connect to the cloud. Step 1, connect the cloud to router interface 0, or sorry, router 0. In the section here in A, I'll just go ahead and tell you, when you're wanting to connect different devices or add devices, you do that by coming down to the far left corner here, and you can click on connections. If you look at the orange lightning bolt there, it tries whatever you highlight to tell you what it is, but we'll click on that. And then we have the slew of different media that we have that we can go ahead and connect. Whenever you highlight a piece of media, it'll tell you what that media is down at the very bottom there. So in this case, the orange line is fiber. We have copper crossover. We have copper straight through and console. Okay, so from there it says in B, choose the correct cable to connect router 0 interface fast Ethernet 00 to cloud Ethernet 6. Cloud is a type of switch. So use a copper straight through connection. If you attach the cable correctly, the link will light up green. That's basically what it's trying to tell you there. So we'll go ahead and we'll select a straight through cable, and we'll go from cloud. It's Ethernet 6. Yep, Ethernet 6 to router 0's fast Ethernet 0 interface. And as you can see, we have green dots. That's illustrating that we have communication and this interfaces are up and running on these two devices. If for some reason you had a red dot, that would mean that the interface was most likely turned off, or there was some sort of protocol that was causing a conflict and not allowing communication to happen between the router and the cloud, and you would have to go in there and figure out what it is and bring the interface up. Okay, from there, let's look at what a straight through cable looks like. So I'll bring it up right down here. Let me switch back. Okay, there we go. So this is a straight through cable, as you learned throughout the chapter. And basically a straight through cable is a cable that has all the wires in the appropriate pin positions the same on both connectors. So if you look, 1 through 8 is all the same as on the other connector, 1 through 8. So you have your orange, you have your green, you have your blue, your green, and your brown, and it's the same on the other end of the connector. Okay, so that is a straight through cable. Going from there, step 2, it says connect the cloud to the cable modem. To do that, we're going to use a coax line. And what a coax cable looks like is that. You've probably seen them in your home, connecting to your TV or to your cable system, or cable provider, that is. In this case, right here, we're looking at a compression connector, which is the modern connector that we use. If you ever see any crimp-on connectors, either change out those connectors, or better yet, throw that wire out completely and get yourself a compression connector. In a digital age, crimp-on just doesn't meet the requirements for digital transmission. It can cause the cable to get sucked out or cause the braiding to fray out at the end, causing ingress into the cable. So we want to make sure that there's always a compression connector. And then as we look at the coax, again, we're just going to jump right into that coax. You can see that you have the jacket, the shielding, and the dielectric, which goes ahead and shields that center conductor from any outside radio frequency that could penetrate, and also keeps the signal inside the cable. So from there, we'll go ahead and click on the coax, which is this purplish blue lightning bolt, and we'll click from the cloud, coaxial 7. Over to the cable modem to port 0. And as you can see, green dots, we're communicating. Excellent. Part 2 says connect router 0. Step 1, connect router 0 to router 1. Choose the correct cable to connect router 1 serial interface 000 to router 1 serial 00. Use one of the available serial cables. Now, there's a whole slew of different types of serial connectors, and I'll go ahead and show you one that Cisco uses. You'll see a whole different types. You know, they're big, they're blocky, they have all kinds of different pins. Typically, I've used this type of serial connector. Within the packet tracer here, it gives you two different types of serial connectors. You have a serial DCE and then a serial DTE. We'll get into later what those mean, those acronyms mean, but just for right now, we'll go ahead and use the DTE cable. So we'll connect it to the serial interface 0 on router 0, and we'll go over to router 1 and connect it to the serial interface 0. And again, we can see by the green dots that we are fully communicating. Step 2, connect router 0 to the server Netacab. To do that, it says choose the correct cable from router 0 fast Ethernet 1 to the server. It goes on to illustrate here further. Routers and computers traditionally use the same wires to transmit and receive. So it uses wire 1 and 2 to transmit signal out, and it uses 3 and 6 to receive information back in. Excuse me. So in that case, we have to use what's called a crossover cable. And what a crossover cable looks like, I'll pull it up down here so you can see, is you have the traditional layout for your Ethernet cable right here. But on the opposite end, we flip the position of the green pair and the orange pair so that the transmission comes in on the receiving end of the other device that you're connecting, and the transmission here comes through on the receiving end of the NIC or interface on this other device. Now, if you continue to read, it says, although many NICs can now auto-sense which pair is used for transmission and receiving, Packet Tracer does not use auto-sense. So it wants you to learn the traditional way of connecting up devices. So for routers to PCs, we need to use crossover cables, as well as from router to router, we need to use crossover cables. So to do that, we'll come down here, and the crossover cable is signified by this dashing black line right here. We'll go from the Netacab server up to the router, and we'll click on Fast Ethernet. Okay, green dots, we're communicating. Okay, next step says step 3, connect router 0 to the configuration terminal PC. Choose the correct cable to connect router 0 console to the configuration terminal RS232. I'll show what a console cable looks like for Cisco. It's a blue cable right here that gives you RJ45 connector at one end, and then a COM port serial connector on the opposite end. Sometimes you'll see a USB. Just kind of depends on the type of router switch that you're working on. And to connect that within Packet Tracer, you come down to this console cable, which is the same color blue as the console cable is physically. So we'll connect that to our configuration terminal PC, to the RS interface, come up to router 0, and we'll connect it to the console port. And you can tell it's connected correctly because it gives you these two black circles signifying that it's connected correctly. All right, part 3, connecting the remaining devices. Step 1, excuse me, connect router 1 to the switch. Choose the correct cable to connect from router 1 F1-0 and switch F0-1. In this case, we're going to use a fiber optic cable, and I'll show you some of the different connectors that we use for fiber optic. So there's a whole myriad of different types of connectors we use. In this case, we're going to use a connector that looks similarly to this type of connector. So to do that, we'll come down here and we'll click on the orange cable, which says fiber. We'll come up to router 1, and we'll connect to the fast Ethernet 1/0, and then come down to here. You can see the two little circles there associated with the fiber optic connector, and we'll connect into that. And in this case, you can see one end of the connector is green, but the other end of the connector is orange. And what's happening is that there's a communication process that is started up between the two different devices. It's exchanging information so that it can properly communicate what type of routes it has on the router, or any kind of IP addresses that need to be issued out to the different devices. And once it's done communicating, there it goes. It gives you the green, letting you know that it is ready to communicate, or send information, that is. From there, we'll go down to step 2, connect the cable modem to the wireless router. Okay, to do that, choose the correct cable to connect to modem port 1 to the wireless router internet port. Okay, to do that, we're just going to use a straight through Ethernet cable. We'll go to cable modem, go to port 1. We'll come down to wireless router and connect to the internet port. And as you can see, both green dots. All right, moving along. Step 3, connect the wireless router to the family PC. Choose the proper cable to do that. We'll again use a straight through cable and connect from Ethernet 1, right? Ethernet 1, yep, to the family PC. Right there. And as you can see, once again, we have one that's green and one that's orange, and that is because it is requesting an IP address from the router so that it can start sending information between the two devices. And we'll go ahead and illustrate that in part 4 here, verifying connections. Step 1, test the connection from family PC to the server, the Netacad server. So we'll go ahead and we'll click on family PC. We'll scroll this over, move this over, and we'll click on desktop. We're going to click on the command prompt. And does anybody remember what the command we used to go ahead and see the IP address? IP config. All right. And as you can see right now, the IP address is 169. That means that it has yet to receive its IP address from the router. And so it cannot communicate outside the network until it gets that layer 3 network IP address. So let's take a look and see, do we have an update yet? Nope. It sometimes takes a little bit. Don't worry about that. Let's see. Anything else we can do while we're waiting? Nope. Peer down. Okay, we have green dots. Does that mean we have an IP address? There we do. Yeah, we have an IP address. We have a 192. So that's a routable IP address that will allow us to get out of the network. Okay, it continues to ask within step 1 here. It says, open the family PC command and command prompt and ping the Netacab server. So you can actually use the URLs. So we'll go ahead and we'll type in ping netcad.pka and hit enter. Now, because it has to associate this URL with an IP address, it does take a little bit longer to go ahead and ping the Netacab server, and then it also has to figure out the route to get over to the Netacab server. So at first it goes to its default gateway, which is the wireless router. The wireless router says, nope, I don't have that on my switch. I don't have that within my network. Let me go ahead and send it out to my cable modem. Cable modem says, yep, let me just send it out to the network, and it goes up into the cloud. The cloud tells which direction to go from there, floods it down to the appropriate router. The router sends it down to the appropriate server, and it comes back. And then you can see, in this case, now we have the actual IP address that's associated with the Netacab server. So if we wanted to, we could actually ping the IP address 254. And voila, it does the same exact thing. From there, we'll go down to step 2. It says ping the switch from the home PC. So we'll close out of the family PC and click into home PC. We'll bring this over to here. We'll click on desktop and then again, command prompt. Okay, so we need to scroll up to the addressing table up at the top here, and it'll tell us the IP address, which is 172.16.0.2 for the switch. So ping 172.16.0.2, right? Yep. Okay, hit enter. And again, it has to figure out the route to get to that switch. So you're going to get a couple timeout requests. Fully normal, it's going to happen. But eventually, if everything's configured properly, voila, like it is right here, we have a response from the ping. Okay, let's scroll back down to part 4, and it says in step 3, open the router 0 configuration. That's basically what we're going to do from the configuration terminal. So we'll go ahead and we'll click out of this, and we'll go to the configuration terminal PC, and we'll click on desktop, then click on terminal, and we'll leave the default settings that they have right here and click OK. And voila, we are in user mode within the terminal interface within this router. So we can type EN to make our way up to privileged mode, that next layer down or up, whichever way you want to think of it, into the layers of the OS. Excuse me. From here, we can go ahead and type show IP interface, which it's asking right here in C. Again, when you type a certain amount of characters that is associated with that command, you can either hit the tab and it auto-completes the rest of the word, or you can just leave, in this case, we want to type the show IP interface brief, but BRI is enough of characters to be associated with that command that you can just press enter at this point. And there we go. We see the 4 different interfaces, physical interfaces that it has: a fast Ethernet 0, 1, serial interface 0, and serial interface 1. And we can see the IP addresses that are associated with those different interfaces. And what is the status right here and the protocol of those different interfaces. So we can see right now those interfaces are up and running. And then, for example, like interface 0-0-1, we can see is administratively down, which means it's been shut down. We'll learn in further episodes what the status up and protocol up mean, but if just for now, as long as you see them both up, that means your interface is operating properly. So we'll exit out of that, and we'll go into examining the physical topology. One thing I want to show you before I jump into part 5 is that within the work environment that they have right here, you can take your cursor, and a lot of times, it doesn't always happen for me, you can hover your cursor over the different connectors or interfaces, and it'll tell you what type interface or what interface you're plugged into on that device. In this case, it doesn't seem like it wants to tell me, so I can go up to Options and go to Preferences. And if you click on the customize, or you go into the customize user experience, you can click on always show port labels, which I like using a lot. You click on that and then just exit out. And from there, you can see it goes ahead and tells you this is coax 7, Ethernet 6, serial interface 0, serial interface 0, fast Ethernet 1, and so on and so forth. So you can know what connectors or interfaces you're connecting into, which is very helpful when troubleshooting. Okay, jumping back into part 5, examining the physical topology. Step 1, examine the cloud. Click on the physical workspace tab. Okay, what it's talking about is up in this upper left-hand corner. You can click on this logical tab, which you're seeing right now, or you can click on this physical tab. And you can also toggle between those two different tabs by hitting the Shift and L for logical and Shift and P for physical. Okay, from there it says click on the home city icon. You click on that and oh, look at this. Let's zoom it out a little bit. You can see right here, it's kind of difficult to read, but it says secondary network, primary network, cloud, and home network over here. And that is associated over with this logical layer with the different devices that we have right here. We have our a home network right here. We have the cloud that's right there. We have our primary network right here, and then we have our secondary network right here. And that's how it is associated with the physical topology right here. Okay, going on from there, it says click the cloud icon. Click on it right there, and look at this. We have a rack, and this rack is what you would see within a server environment or a node within a network. And you can see right here you have a cloud switch and the different interfaces that are plugged into this switch that we have, this cloud. If you hover over the different connectors in this environment, it'll tell you what the source device, in this case, is the cloud, the source port, which is fast Ethernet 6, the destination device, which is router 0, and the interface that it's plugged into, and even the length of the cable and the type of cable. From here, you can do things like turn off the device, as well as, in some cases, actually hover over and see what type of cards that are associated with those different slots. Okay, so from there we have these navigation tabs up at the top here. We're going to go ahead and click the back tab to go back to our physical topology. Okay, from there we'll go to part 2, or step 2 that is. It says click the primary network and hold your mouse pointer over the various cables. What is located on the table to the right of the blue rack. So we'll click on the primary network. There we go. And we'll go ahead and zoom out, and we have the router 0 and the Netacab server. And right here we have our configuration terminal desktop. And again, it's associated right with the logical link. We have those 3 different devices right there. And as we switch back over to the physical, I think we just answered a question. What is to the right of the rack on the blue table? It's our configuration terminal PC. If we look in a rack, and I'll go ahead and I'll zoom back in here, we can see our router 0 and the server and the different connections that are plugged in here. So we have our serial interface that's going to router 1. We have our console cable that's connected to our PC, and we have our crossover cable that's connected to our fast Ethernet going down to the server. From there, we'll just go ahead and click back and go back to the physical topology. And it says in step 3, examine the secondary network. Click the secondary network, hold your mouse pointer over the various cables. Why are there 2 orange cables connected to each device? So let's go ahead and click on that. Oh, there we go. And there's our rack. We have our router 1, and we have our switch. We have our serial interface, which is coming from router 0. And then we have right here the answer to the question, the fiber optic cables that are going from the interface on the router and making its way down to the switch interface right there. So that answers that question. So we'll click on the back and move our way back. And then step 4, examine the home network. Why is there an oval mesh covering the home network? Well, let's cursor over and zoom in. We'll see what we're dealing with here. We have this blue mesh that's over the home network. Let's go look at the logical layer and see what could be causing that's different from the other 3 sites. Well, if we look, we have a cable modem, we have a home PC, we have family PC, and we have a home printer. But the thing that makes it different is this wireless router. And that is what this blue oval is trying to illustrate, is the wireless transmission that's being caused by that wireless router. In B, it says, click the home network icon. Why is there no rack holding the equipment? Well, let's go ahead and zoom out. And as we can see right here, we have family PC, home PC, our cable modem, and the different cables that are connected to that cable modem, as well as our home printer and our wireless router and the different wires that are connected to that. And to answer your question, while most homes typically don't have racks in their houses, right? We're putting our modems and our PCs on desks in our offices or in our entertainment center or even underneath our desks, things like that. And hopefully you're not putting your wireless router underneath your desk because it's terrible for reception. Put that thing centrally located. So that is the answer to that question. Cable modems are typically meant to be rack mounted. They're meant to be placed on shelves or on tables somewhere. They don't have rack mounted racks that are on the sides of the devices to rack mount them. And plus, I don't think you're going to rack mount a home printer. So moving on from there, it just says, click on the logical workspace to return to the logical topology. We do that, and we're back to the logical topology, and we are done. If you look at our completion, we're 80 out of 80 points. So we have completed this packet tracer. I hope that I help illuminate some of the information that you went and read through throughout the week and help illustrate that to the actual lab itself. If you have any questions or comments, you can send me an email to notciscoacademyhelp@gmail.com. And you can also, if you have any comments, you can leave them also on the video YouTube page. I hope that this was informative and helped you. Again, I'm not like other guys. I tried to illustrate this information, so it's going to take a little bit longer to work through it, but I hope it's beneficial to your learning experience. And saying that, I appreciate your time. I hope this was informative, and have yourself a great day. All right? Bye-bye.